Hello students, welcome to Sourav Sir's classes. The question is, let an be a sequence of positive real numbers such that limit n tends to infinity an to the power 1 by n is equal to 1 by 4. Then the function fx is equal to x sine 1 by x squared where x not equal to 0 and at x is equal to 0 limit n tends to infinity log 1 plus an by sine an plus pi by 2 is, well, so since an is a sequence of positive real numbers, an greater than 0, and we also have been given that limit n tends to infinity. I'm extremely sorry for this. An to the power 1 by n is equal to 1 by 4. Now taking log to the base 2 on both sides, we get 1 by n log 2 limit n tends to infinity an is equal to log 2 2 to the power minus 2. From this we get 1 by n log 2 limit n tends to infinity an is equal to minus 2 log 2 to the base 2. Now this gives us 1. So on the right hand side we are left with minus 2. Therefore, limit n tends to infinity 1 by n log an is equal to minus 2. Now as n tends to infinity, log an tends to minus infinity, or an tends to 2 to the power minus infinity, that is equal to 0. Therefore, f0 is equal to 0. And limit x tends to 0, fx is equal to 0, since this when x tends to 0 gives us 0 and this also gives us 0, because an is 0, so the numerator becomes log 1, which is equal to 0. Now, so the function is continuous. Hence, continuous. Now, checking for differentiability, so f dash x is equal to limit h tends to 0 fh minus f0 by h minus 0. So now f0 is 0, so limit h tends to 0 h into sine 1 by h squared by h gives us sine 1 by h squared, which does not exist. Therefore, the function is continuous at x is equal to 0 but not differentiable at x is equal to 0.